Dear experts, good afternoon. My name is Gao Jianguo. I'm from WONTAI Power. Our company was founded back in 2015. In the early days, we were engaged in the development of renewable energy. Our business covers both wind and solar. So in our practice, we have seen the potential of energy storage very clearly. The share of renewable energy in the total energy mix has been on the rise. That means a lot of room for growth in energy storage. We have done a lot of research and surveys to understand demand better. Back in April 2021, we started our VRFB project officially. So that's less than 2 years ago. So you can see we are kind of a rookie in VRFBs, but we have done a lot and gained some insights. Our company has two major parts, universal energy and WONTAI. Under the banner of universal energy, we have a lot of capacity for renewable energy, as you can see here, over 1,200 megawatts. And under the banner of WONTAI, we have been doing VRFBs over the past few years, and we can go up to 72, actually 17 megawatts and 72 megawatt hours. We have our mine in Dunhuang, that's known as Dunhuang Wei Mountain Vanadium Mine. The reserves could go up to 450,000 metric tons. At the end of this year, we have finished designing our whole mining plan, and the construction and the production will start next year. In Jiaxing, Zhejiang, and Jiuquan, we have our energy storage plants or factories. In Jiaxing, we have a very large capacity, as you can see from this page. Also, we have a plan for building an electrolyte factory. It is in Jiuquan of Gansu. The total footprint is about 100 mu. Mu is a unit for measuring area. 1 mu equals 667 square meters. And also you can see we have some assets overseas. In renewable energy, we have 1 gigawatt, and 50% of that is in overseas assets, mainly in Kazakhstan. We also have EPC capabilities. So that is our engineering branch. So our EPC arm has done quite some projects. We can do equipment, design, construction, installation, and all the other major things. Each year, we made investments in over 300 megawatts of wind and solar, and actually, in that amount, we could detect huge demand for energy storage that can go up to 50 megawatts, and the duration is like 4 hours. Our procurement is market-based. So in our solution, we may use products and components from across the market. We have also done some policy registration. Altogether, we have more than 125 megawatts of capacity registered with authorities. As you can see, from mining to the electrolyte equipment, EPC, and power station operation, we have a full chain of operations. That is about our company. We are an equipment supplier, and we are also an equipment user. So I want to go into the nitty-gritty of the market. In this year and by 2030, I'm sure the market will have more transformation underway. On the user side, our company has done a lot of projects. One of the early projects was a user side project. It's just 12 actually 2 megawatts and 12 megawatt hours. This project has already been accepted by the client. Anyway, from the perspective of the user, there are a few concerns. First, safety. Second, ROI. And third, maintenance and operation. Safety may matter more for electrical systems. A lot of users, they are not electrical experts. They may be in the sectors of like food and beverages or clothing. When they want to have energy storage, they really care about safety. Also, their facilities tend to be densely populated areas. Therefore, safety could feel even more important. And actually, that could be where we can give full play to our advantage. As for the ROI, on the user side, they gotta spend a lot of cash on projects, and they can have some kind of energy arbitrage to recover some of their investment. However, costs could come from different parts of the system or the project. We need to ensure they can get a good ROI. In certain places, there are subsidies from authorities. The subsidies cannot be here forever. We want to ensure the whole design makes good sense. And as for maintenance and operation, we gotta ensure that can be done very effectively and efficiently. And on the user side, when we look at all the details of the micro market, there could be a lot of details. Compared with other technologies, actually, lithium-ion batteries have a clear advantage, have some clear advantages, but those batteries may depend heavily on subsidies. This market could be hard to crack into, and the future has a lot of uncertainties. On the power generation side, we need to ensure that all the equipment is in place and all the profits can be shared reasonably. We gotta ensure the market is promising and the policies are supportive. Energy storage power stations may have no returns. It has only costs. And in developing energy storage, in developing energy storage, we need to consider the costs. And for state-owned companies, they need to consider so many tricky issues. A lot of facilities have been installed, but those facilities are left unused. Maybe this year it's only about 10%. I mean, the utilization rate is only 10%. As for the independent energy storage process in the system, in the grid system, I suppose there could be a lot of opportunities. As for frequency regulation on the power grid, there could be maybe dozens of such actions per day. According to my experience, there could be 30% of, the whole system of the electrical system could be healthy around 30% of the time. For the rest of the time, there gotta be a lot of frequency regulation. And also, we got to consider energy storage investments from the perspective of payback years. For investors, they care about profits. They care about returns. According to our calculation, if we compare lithium and vanadium, maybe the payback period in the case of lithium could be much shorter, around 5 years. But in the case of VFBs, the life cycle could be like 15 to 20 years. So for those systems based on lithium, 5 years is very short. That could also spell a very short life cycle for the whole system. But for vanadium, we need to spread the costs over 15 to 20 years. In that case, we can see VFB costs are not so daunting or onerous. If we gotta develop lithium batteries, we need to go up to a very high volume. Price should get a secondary place. A market would be huge. A market could be worth 1 trillion yuan. But in developing a better future for lithium batteries, we need to achieve a very large volume. That could be hard in certain scenarios, and that could be quite a struggle. Plus, we need to look at the pricing mechanism. Let me give you an example of the cables. When we buy cables, we need to pay 20% advance payment in the next 6 to 8 months. We will have some locked-in prices, regardless of market fluctuations. That is a very good practice. But now, in many investment projects, we may not have the luxury of locking in prices. When the project is already under construction, if the owner does not know the actual price, that could be very sad and even a little bit messy. Many experts talk about the cost of the electrolyte. Electrolyte accounts for 50% of the whole energy storage system. I'm sure that in the future, there's going to be new capital pouring into electrolyte. I don't think it's a good idea to have in so many investors in this niche market or niche market segment, because electrolyte has a radius for transportation. It is important to transport that for a really very long distance. The electrolyte is a chemical. Transportation could be really expensive. And actually, if we want to do some measures to get more value added from that, it's very hard. And we may talk about 500 to 1,000 kilometers of transportation, but that's not feasible at the moment.
So the first one is about the DOD. Actually, for the lithium, it's just 90% of the discharging depths, but now we're claiming that the vanadium has 100%. It might be a technological advantage, but how can we show it in the market and form a competitive advantage? We are not doing very well so far because 100% of the discharging depth has 10% extra of the electrolyte use. So maybe we can just benchmark with the lithium by 90%. As for the conversion efficiency, likewise, we could know it for sure that actually WONTAI has some bidding from the lithium suppliers, and we know the calculation method, and we do our tendering, but we need some calculations different from vanadium. And if it's over 40 or 45 degree Celsius, the lithium, even though there's no charging or discharging, it needs the air conditioner on. Therefore, the sealed container and the AC should be turned on inside, and the conversion efficiency hasn't been calculated. Therefore, number 7 is how can we give play to the high residue value? Now we talk about high residue value, and the professionals know it very well, but on the accounting statement, it cannot be shown to investors and users. It is not in line with the assessment needs of the professional managers. Therefore, for the vanadium players and VRFB players should understand it and should use it and show it. The last one is we have a little recommendation for the VRFB industry. In some aspects, we could do more sharing, especially in terms of supply chain. And now the supply chain is in the rapid evolving and preliminary stage. And we do have some fields that really something to do with the technical secret. So maybe we could do more communication, such as a storage can, or the storage is very high. So one can is one tank is dozens of cubic meters. So if the eastern enterprise goes into northwest and we cannot just transport from eastern China to northwestern China for 4,000 km for this for the empty tanks, but I cannot have vendors of tanks everywhere. So maybe you can offer some suggestions in what kind of options we have. So basically, that's what I need to share. And the next thing is the site and the facility. This is our facility in Jiaxing, Zhejiang, and you could see this is a systematic integration for our users, and also you could see the qualified stack photo. And the next one is in Gansu Jiuquan, and this is the workshop has been sealed, and it will be put into operation in May. Thank you. Okay, thank you, Mr. Gao, for your wonderful sharing. And now let's go into Q&A. So our friends online and offline, any questions for Mr. Gao from WONTAI? Any question? Okay, Mr. Wang. Hello. Well, thank you for sharing. Actually, I truly agree with you. Would you please talk about some difficulties or barriers you have? And if we are aware of this difficulty, we could we could do our job better. Yes, we have just a few exchanges. If we have 2 more meetings, we'll have a more trust between each other, so we can share information better. Thank you. Okay, next question, please. Hello, and thank you, Mr. Gao. And we have learned a lot. My question goes like this, and IRR of the power generation and independent storage IRR. Would you please go back to that slide? IRR, yes. I couldn't understand why the power generation IRR is not as good as considerable as independent storage, because in terms of policy, the independent the transmission cost is taken into account for the IRR or the returns. And it's the first question. The second question is that for your calculation of vanadium battery return rate, compare vanadium and lithium battery. Are you calculating on the basis of all life cycle of storage project, and considering the repeated investment of lithium battery, how many times do we have to invest? The first, maybe my understanding is not correct, and the power generation, and there's no IRR because the storage and the power generation side doesn't cause any yield or returns. It is just a requirement of a grid. So it has been incorporated into the PV or the wind. Ultimately, we need to look at the IRR of the wind farm or the PV panel. This is why IRR is not mentioned there. That is the first question. And the second question is for the grid and green side. In different provinces, they are launching different policies, such as in Henan province, it is a very good policy. In Gansu, it is also launching different policies will ask for different IRRs, and also such as capacity subsidy and peak shaving, frequency shaving subsidies, or some commitment. How many times should we change the or shave the peak every year? So that is the first question. The second is about the oil life cycle. Oil life cycle. If we do the calculation, we always calculate the oil life cycle, but we need to be based on the accounting costs. The residue value of electrolyte will be long after 20 years because it is just a depreciation as 5% depreciation as asset on the statement, financial statement each year. Okay, any other questions? Okay, actually on this slide, I have a question. For instance, for the grid side IRR, lithium and vanadium for IRR, lithium and battery vanadium are similar. What is the IRR percentage point, or is there a range? Well, generally speaking, if we have over 10%, you can do it, and if it's less than 10%, you cannot do it. Yeah, it's 10 percentage point. IRR is a very good project. That is just a partial IRR with subsidy. Yes, such as the capacity fee is higher, and also peak shaving or frequency shaving must be committed. Yes, actually, according to our understanding, the grid independent power storage has a very complicated interfaces, and also we need to have a guarantee about the subsequent returns or yields. Anyway, we need to have a case-by-case attitude. And WONTAI, do you have any project of independent power storage project? Yes, we have done some registration, but we haven't studied any construction yet for the independent storage projects. Okay, any other questions in this conference room? Any other questions here among our audience? If no, okay, now let's have a break.